Okay. So, I mean, basically, the idea behind this design session was to talk more about what we had talked about in the Xen community call with respect to open sourcing the Bareflank work that we're doing into the Xen project in one way or another, and kind of getting a feel for what people's preferences were and how you'd like to see it done. Did that go through?
I can hear you. Will it go through?
Basically, I was just saying that the idea behind this design session was to discuss more about how we would go about open sourcing the Bareflank Xen PVH work that we've been doing back into the Xen project.
Oh yes, we heard that. I heard that. So.
Okay.
Yeah, I heard that as well.
All right, awesome. So, I mean, when we talked during the Xen community call, there were essentially two different options. I probably could go through just a real quick update.
Can we have someone to take some notes? I guess I can volunteer, but that'll limit how much I can.
Yeah, each of the design sessions wants someone nominated as scribe, and probably best to use the shared notes folder. So it's on the left-hand side, just under public chat.
Yeah, but it shouldn't be someone who's heavily involved in the discussion, because it's just hard to take notes and discuss at the same time.
Yeah, who can actually hear the audio to take the notes? Hey, Brendan, can you do that quick for us?
Sure.
Okay, awesome. Thank you. So I probably should start by just doing a quick refresh as to what we've done up to this point for those who aren't on the community calls. But basically, under the Bareflank project, we have re-implemented the majority of the Xen PVH hypercall interface, using the Bareflank hypervisor instead of the Xen hypervisor. And we did that because we essentially needed to sort of implement a different hypervisor design while still wanting to kind of support our existing Xen virtual machines that we use for OpenXT and other projects. And really, some of the big things that we tried to accomplish as part of the project was, at a high level, was removing the need for Xen to have a scheduler or power management code and letting sort of like DOM0 handle that for us. Another goal that we had in mind was a Windows DOM0 instead of a Linux DOM0. And we also wanted the ability to start and stop the hypervisor without having to reboot the computer. Since we're doing a lot of heavy development, constantly having to reboot the computer can be something that really slows you down quite a bit. And kind of above and beyond that, I think those are probably the really big things that we're trying to do. I mean, in the end, the Windows DOM0 part of it is the thing that we cared the most about, above and beyond the scheduler and power management stuff, and that was for device support. So we really didn't want Linux running due to the fact that for some devices that we're trying to support, device support just isn't that great. And so we basically took the Bareflank SDK and implemented a prototype that allows us to essentially, execute Xen virtual machines, and they think they're running in Xen. And so when we finished this kind of work, we thought to ourselves, okay, how exactly do we want to go about sort of upstreaming this? The one idea is that we could just put it into our own project and kind of maintain it from there. But we were talking with the team and thought that maybe it actually would make sense to kind of donate it to the Xen project instead in some way, whether it be through some sort of sort of like sub project within Xen, or work over time to actually sort of like upstream these changes into the Xen hypervisor itself, and not use Bareflank at all. So, and we're kind of amenable to both approaches, and and if this isn't code that the project's interested in, then we could always obviously do it ourselves. But we think it'd be a benefit to the Xen project, kind of moving forward. Thoughts?
From a point of view with a Xen project hat on, having some of this contributed upstream would be lovely.
Yeah, I mean, personally, I don't have a strong, I don't care much about running under Windows, but it would be really great to be able to have people boot just a normal Linux system and say, it's mod Xen, and then like, bam, now you're running Xen, rather than, and then unload Xen and reload a new Xen, rather than having to reboot after you install. So making it so the Xen knows how to do that under Windows would make it a lot easier for someone else to make that same thing possible under Linux. I don't have it. So at the moment, is it true that you have a prototype that can? Does a prototype is a prototype a Windows module? So you boot Windows normally and then put this underneath Windows, or is it first booted and then boots Windows on top?
We support both. So if you're using PCI pass-through at the moment, you have to boot it first, only because of the way we set up sort of like a PCI back, kind of similar way Xen does. That's not we could actually remove that, the need for that, and while still supporting PCI pass-through. We just haven't put the glue logic in to be able to have that sort of PCI back, reserve a driver, and then allow us to move it later. But if you don't use PCI pass-through, then yeah, it's essentially a Windows driver that loads up the hypervisor, and then from there we start like a virtual machine that's just a small little Linux VM that sort of acts like DOM0 in a sense, where it starts up Xen Store and it runs XL and is is able to create virtual machines as needed, but those virtual machines are sort of like attached to executables running inside Windows that are dummy applications. All they do is they're there to be blamed for the time that is being executed to actually execute the virtual machine. So it doesn't have any data in it, doesn't do anything other than just when it is executed by Windows, it tells the hypervisor to run a VM.
Okay. So I mean, how much of the code that in this prototype is upstream Xen code versus how much of it is code that you've written, and how much would have to be rewritten or changed for the upstream Xen code to make this work?
All of the code we wrote ourselves. I mean, obviously we used the Xen source code as a sort of a reference when needed, but it's all brand new code that we wrote. So, and it would probably all need to be rewritten to some degree because the Bareflank hypervisor is written in C++, and so we would have to port, what we did to the Xen project itself. We didn't use Xen and try to like manipulate it into this form. We started with the Bareflank SDK.
I see.
But that being said, some of the stuff that we wrote, Xen already has. So there's obviously some logic that would need to be added to, Xen, to do things like, for example, the sort of rootkit effect. Because unlike KVM, which is just a module that loads and then from there runs guest virtual machines, Bareflank and the other projects that it has, they all, when run in that sort of late launch approach, they all basically VMX rootkit the host operating system so that it's now running underneath the virtual machine, which allows us to control the virtual machine the same way that we would, sort of like DOM0, the same way Xen would, but does it at a late launch instead of before the OS boots. And I don't think Xen has that today, so that's something that we would have to sort of implement to be able to get the Xen hypervisor up and running. And once we had that, then there would have to be some ABI changes to support additional hypercalls that Xen doesn't have today that would allow us to, say, for example, tell the hypervisor to run a virtual machine, because it won't be able to do that on its own since it won't have a schedule or any power management code.
So to your earlier point, Xen at the moment has absolutely none of the rootkit logic in it. I know that Bromium does, so there might be a bit of a reference implementation in their public source posting. I haven't looked at it. I don't know what's there and if it's something we'd consider reusing.
Yeah, I mean, the rootkit logic isn't that complicated. It's pretty much identical across all projects that do it. I mean, there's our project, there's also SimpleVisor and Hyper Platform. They all kind of do something similar. And then, obviously, all of those projects are based off of More, which we wrote a number of years ago, and which was originally based off of the VMX rootkit that was written by Sean Embleton back in like 2007 or something like that, very long time ago. And yeah, it tosses DOM0 into a VM. In our particular case, everything is PVH, so there is no PV, and includes DOM0, and even when you're running like sort of in the Linux mode. At the moment, there's no HVM, but we're working to add that this year this next coming year, as well as nested virtualization for Hyper-V.
Okay.
And it's designed so that we try to get as much performance as we can with that architecture. So one big difference is that DOM0, we worked very hard to ensure that external interrupts were not enabled for that particular VM. So if an interrupt occurs while DOM0 is actually executing, then it's not trapped to the hypervisor, which has a pretty substantial improvement on performance compared to trying to tromp on essentially every single interrupt that would fire in the box, which is something we tried to avoid at all costs. And so far, we've succeeded in doing that, including with PCI Passer.
So it means that the physical local IP is managed by DOM0, I guess, and not Xen?
The physical APIC is managed by DOM0, yes. We can obviously intercept that if we need to, but at the moment, we haven't had a need to do that.
I mean, is there any device that's managed by Xen when you use that model, or everything is managed by DOM0?
Are there any devices that are managed? I mean, obviously,
The
well, no,
IO
I mean,
view
so
is,
yeah.
I guess, but
Mm-hmm.
and obviously the pass-through devices would be to the guest VMs, but pretty much all of them are in the root or pass through to DOM0.
So you basically allow DOM0 to, for example, configure the MSI of the devices directly, I guess. There's no interception there.
For the ones that it's managing, for the pass-through, we intercept the MSI's programming, but
not for DOM0.
correct.
Mm-hmm. I mean, that would be slightly different from what we do on PVH DOM0 on Xen at the moment, where we intercept all of those, like we would do for pass-through to untrusted devices.
Yeah, I mean, we probably should do that for in a security scenario. The default configuration just doesn't right now.
I mean, we would, if we were to add logic like that, which wouldn't be that big a deal, it would be there to simply ensure that the configuration was valid, not necessarily to reconfigure anything. We'd still let DOM0 kind of decide what it wants.
So you would just like proxy the write to the PCI config space, I guess.
Yeah, yeah, it'd just be there as a sanity check to make sure that DOM0 wasn't misbehaving. So I guess that's the, so I mean, the ability to fire up the hypervisor in this mode, one of the big benefits that we've seen right off the bat is the sort of performance and battery life on more like mobile machines has been fantastic, near native, frankly. And that was one of the driving reasons for that design architecture, is try to keep the amount of exits as small as possible, with some of the big ones being this sort of external interrupt issue. And then in addition, letting the operating system that was built for the device manage the device with respect to scheduling and power management. And because, some devices have some very bizarre behavior there. A good example is I have, a Dell laptop with a Core i9, and there's some pretty aggressive scheduling that's done in power management logic to keep that chip from overheating and going into, thermal management on Windows. Something that even like Linux still struggles with to some degree, although the latest kernels seem to be getting better.
Yeah, I can confirm my laptop's currently suffering from that. I need to update Linux.
Yeah, when I first got this, it wasn't until 5.4 that it was starting to get somewhat better. It's still not, like, Windows still can do about 3 hours more than what Linux can do, but it's not great. And so, Xen managing all that isn't going to be all that fantastic. I would think it'd be a pretty big undertaking for Xen to build power management logic that was suitable for any device that was out there, including everything from a mobile tablet all the way up to a server. And so in this model, we don't do that. We let the operating system that was originally designed for that machine that has the best power management likely that you could get to do all that work instead. And another benefit that we've experienced on OpenXT is that the Xen scheduler and the DOM0 scheduler can sometimes conflict with each other. And one of the better examples of that we used to run into a lot is with audio, where there's a very specific sort of like real-time requirement to be able to get data into the audio card. And sometimes when the system starts getting bogged down pretty heavy, audio data coming from, say, like an HVM, and then trying to be transitioned into into DOM0, which might require 4 or 5 different world switches just to be able to pull off the transaction. That application that's running inside DOM0's user space, it still needs to be scheduled just the same as anything else. And the conflict between what Xen's trying to do with getting whatever virtual machine scheduled, and then with DOM0 trying to do its scheduling, can be somewhat problematic because it's hard for the system to know that there's something that needs to be executed right away. By removing that and having just one scheduler that maintains all that logic, it has a lot more contextual information to know that, hey, I've got to do something like right now because I'm running out of time, and so you can get somewhat better performance there as well.
Right. Well, at least the scheduler has more information about that particular. It has the DOM0, the scheduler for DOM0 processes knows that about DOM0 processes, but it doesn't know anything about the VMs. But yeah, that's certainly better. Was that, out of curiosity, was that with the credit 1 scheduler or with the credit 2 scheduler?
The performance difference that we saw, or honestly, I don't know. It's whatever default Xen comes with.
Well, that switch, was it 413 that switched, Andy? 412, one of those.
I think that it probably was credit 1 at the time.
Say again?
I think it was credit 1 at the time.
Right. Okay. Credit 1. So credit 2 was designed to have slightly better, when I was designing credit 2, I actually had sound running in a VM and I was testing it under load. I haven't tested it in a long time, so it may still be terrible, but it might actually be better.
Yeah, we have to play with it. Our audio logic's changed pretty dramatically in OpenXT over the years. So, and it was working actually originally. It's just if you started to get things bogged down, that's when you start to have some issues.
Of course, yeah.
So those are some of the driver reasons for why we went down that path. And so far, like I said, it's worked out pretty well. But ultimately, we think that kind of like trying to find a way to get this into your guys' project might be the better path long term. Mainly just because we'd rather not maintain our own implementation of Xen alongside whatever it is you guys are doing as well. The other side of this is that I think there's a driving need for, sort of like a revisit on the Xen ABI in general. As we did this implementation, we've actually, I think we provided some of the details, although it's been probably about a year since we've updated it, as to what hypercalls are actually being made. There's a fair amount of Xen stuff that's done that's just not necessary for PVH and HVM. That would probably simplify the PVH HVM architecture in general. And so it might be worth at some point, also having a longer, discussion about the ABI in general for PVH and HVM to see if there's improvements that we can make to make it a little bit more simple and a little bit more optimal for those environments. So does anybody have a particular preference as to how you'd like to see us upstream this work? Would you prefer to see a sub-project, or would you prefer to see us actually upstream this into the project itself, the mainline project?
Personally, I think a sub-project is overkill. We're looking at 2 or 3 large areas of work, but all fairly self-contained in one part of the hypervisor or another. I don't think the overhead of a separate sub-project is going to be useful here.
I think I will agree with that also.
Yeah, so I mean, I think as Andy said, I mean, it seems like basically using the same code that you already have as far as to do the to do the blue pill thing, and then just hooking in somewhere else into the Xen boot path should be pretty self-contained, and it would make it would have a lot of benefits to both of our projects. You guys wouldn't have to maintain a full hypervisor, and we would have a lot of the features that might be kind of cool. So the scheduling stuff, the Xen scheduler is quite I mean, it's fairly well isolated off as well. So we already have 4 or 5 different schedulers inside of there. So it seems like it shouldn't be terribly difficult to make it possible to have an external scheduler where where you hook off of some other processes, sort of like the DOM0's scheduler rather than running that itself.
Ultimately, for scheduling like that, what you will need is to execute a vCPU in the context of a hypercall from DOM0. So you'll have a hypercall that says run this CPU. That is quite different to what we've got at the moment. I'm not sure how well it would integrate easily. You probably need the concept of a vCPU tied to the current vCPU. So you've got one vCPU does hypercall points to another CPU. We schedule that other CPU and schedule back on exit, because ultimately, from DOM0's point of view, it needs to look like a hypercall and one single system call to the hypervisor.
That's exactly how Bareflank works today. There's what we call the sort of like root vCPUs. They are created for every single physical CPU that's on there, including threading, and they're non-optional, meaning they have to be created. And the sort of like DOM0 OS runs with those in those sort of like root vCPUs, and they act very differently compared to all the other vCPUs that are on the box. And then it will it'll basically go and create a sort of virtual machine and tell the hypervisor how would like to see it configured and created, and similar to what Xen does today. And then from there, and that's all done in a driver, so that we can reserve non-pageable memory, and we can donate that to the guest. And then from there, this sort of application is run, and it is really all it does is it just VM calls up to the hypervisor to say, hey, run me. And it gives it a sort of like a DOM ID a vCPU ID. And what happens is that the hypervisor goes and schedules that vCPU to run. And when an exit occurs, and there could be different reasons, usually the one that happens the most is an external interrupt fire, we return back to that sort of root vCPU. And there's obviously nothing stopping at the moment from sort of creating that sort of G-node style architecture where you could have a virtual machine that creates more virtual machines, that creates more virtual machines if you wanted, and sort of capability based, so it keeps dissecting its resources.
That's actually how it works now too.
Yeah,
there's really only one sort of management VM created from Windows, and then that looks like DOM0 from a Xen interface perspective. That's what hosts XL, and then further VMs are created by XL running from that VM. It's like a tree structure.
Yep. So, I mean, I guess the answer is that we'd like to see this moved into the hypervisor itself. So, which is fine. So, I guess the first sort of area for us to probably play in to start would be to get the rootkit portion working, only because that'll make dev on the rest of it a lot faster and easier. And then once that's done, then we can start working on the extra hypercalls that are needed to fire up a virtual machine and run it from the DOM0 perspective instead of from Xen's point of view. And then, kind of just plumb the rest. When it does come time to sort of add these additional ABI stuff, how do we want that to be done? I know changing ABIs can be a pretty complicated thing. So,
I mean, you just need to add new hypercalls, or you need to modify the existing ones to do something slightly different?
We don't need to modify any. We'd certainly like to change some to clean up the interface, but that's a secondary task. We need to add some.
If you need to add some, it's pretty non-controversial. You just add the hypercalls, and that's fine. Extensions are fine.
Yeah, we add hypercalls all the time.
Oh, okay. All right, cool.
Yeah, on the subject of ABIs, I know this is something we have discussed before and will continue to discuss. Currently, we're looking at two separate but major ABI changes. One of which is to make the tools ABI stable, so we can do more sensible updating of software. At the moment, whenever you install a new version of Xen, and indeed the user space libraries in DOM0, you can no longer manage the VMs until you reboot. And this is a big problem for a lot of downstreams. So that's one area we're looking into, but that's fairly well constrained to the tool stack and the DOM-CUTL, sysctl style interfaces. The other major area we're looking at is the general HVM ABI. The history there is that large amounts of what we have in HVM at the moment was taken by starting with the PV ABI and hitting it until it worked. This is not a great design. It has a number of problems. Most critically, at the moment, it is still virtual address based, which means we cannot use any of the encrypted VM support that's starting to come along in hardware. So I realize I am distinctly behind in my initial plan to at least try and describe some of the problems and send them for discussion on the mailing list. But we definitely need to come up with a new ABI to support encrypted virtual machines. As that is a break in the ABI or a new V2 ABI, we might as well get everything else correct whilst we're doing it. So there will be long discussions over how and what we do to change it, and it might be that we just have a brand new type of VM, call it V2 or something. That might be the best way of going about it. But what we would like to do is identify all the areas we want to change and see what is the best way of going about making that change.
Okay, so I mean, from our point of view, then if we can just add the hypercalls as needed, then that's not that big a deal. And then when it comes time to maybe do a cleanup of that stuff, we can take a look at some of the stuff that we did and help, with that effort, because we've learned a lot in the process of implementing it, and a lot of the things that are either not necessary or could have been implemented in a way that would have made things a little bit more performant and a little bit easier on the hypervisor, instead of the way it is now.
The way it is now is not an example to copy.
So, I mean, I think that pretty much concludes this talk. For us, the next step would be to start working on actually, making these changes and getting them pushed upstream. And so I'll obviously work with you guys over XenDevel to do that. That type of work probably won't start until about next year. We've got some things that we've got to get done this year between now and then. And internally, we still have to figure out exactly timing-wise. We are moving very quickly with the stuff we're doing, so there might be continued effort to finish up what we're doing on our end, and then start to upstream or do this right off the bat. I don't know. We have to have those conversations internally. So when exactly these changes would make it to the project next year is up in the air. But that would be our goal, is to start working with you guys then to start doing this.
It would probably be useful as a first step to do an email to XenDevel covering the vague areas, possibly in slightly more detail than this. So, for example, do you want a build of the should we make a third build of the hypervisor that is that has the scheduler taken out, for example? Or do we want, because the thing is, this is quite a lot different to how Xen currently works, and it might be worth having a dedicated kconfig base that, for example, has all of Xen's boot path taken out, or most of the boot path, because that won't be relevant for a lot of the setup proposed here. So that might be the best way of having something that's not a fully fledged hypervisor.
Yeah, I mean, I don't know. The boot path probably would still be useful. We obviously support this sort of type 2 late launch. I mean, type 2 is the wrong word, but this sort of late launch approach. But we also very much use the early boot. And in fact, in our sort of like deployed systems, that's how it works. So the sort of late launch is good for developers. In our use cases, we wouldn't want to deploy it that way. So I could see the boot logic still being useful, but certainly a kconfig option that would allow us to get rid of the scheduler would be useful.
So at the moment, there's some broken kconfig logic that no one's ever got around to fixing. That won't be too hard to take out all the schedulers with.
Yeah, so that would work. And once we had that, then we could add, kind of like what we need. There would probably want to be some sort of kconfig option added to add these additional hypercalls. I wouldn't leave them turned on by default because they're sort of adding additional capability that the existing schedulers would probably not know what to do with. And so, having sort of this extra kconfig option to add the additional hypercalls that are needed would probably be a good idea.
Yeah, that's fine. We've got top level kconfig options for a number of subsystems.
And then I'd probably do the same thing for building the driver, that kind of thing. If you off by default, but if you turn it on, then it'll build the driver and sort of add the logic for Xen into that as needed. Currently, the way Bareflank does that, by the way, is that it takes the hypervisor binary and produces like a blob that it can shove into the driver. And then from there, the driver moves that blob into memory and sort of executes it. At the moment, that relies on executable memory to do it. That's something we're actually working now to remove, so that the only thing that would be needed would be like a write to CR3. But at the moment, it does require sort of like executable memory so that you could put that blob into memory somewhere and then be able to execute it from an exit. And so I'd be curious to see how you guys would want to see that done. I know that when that one kernel, Linux kernel thread was going about the split lock detection, that people started to freak when they found out that some hypervisors are using executable memory like us in VMware. And I don't know if they're going to want to allow us to do that moving forward, or if that's something you think they might try to remove. And in which case, this approach from an upstream point of view might not be the best one, and instead using this sort of move to CR3, where you write your own CR3 and then jump back into the guest, might be the more appropriate path for Linux kernel in general.
I mean, a lot of that will come down to exactly what upstream Linux want to do with respect to their module handling, but one way or another, they can't actually afford to break VMware. So one way or another, there is going to be a mechanism that works for hypervisors of this style. It may not be exactly the same as how it looks right now, but there will be something that works.
Yeah, I mean, the executable memory one is kind of interesting because I'm pretty sure that's how NVIDIA handles their stuff too, to get around the GPL problem. So I'm not sure if they'd even be able to prevent that or not, but certainly if the only thing is a move to CR3.
Okay, guys, it's 4:30, so it's actually the next thing now, I think. So Brandon, sorry, Ryan, do you want to finish up real quick, and then we can actually start. If we still have lots more to talk about, we can actually have another session later if you want to.
I think most of the questions that I was looking for are answered. If there's any more questions for us, if you go to our GitHub project, our Slack channel link is right up there. Feel free to join our Slack channel and jump on and ask as many questions as you want. In the meantime, we'll be contacting you guys at some point to start working on integrating this stuff up into the Xen project.
Okay, great. Looking forward to it.
Thank you very much.
Yep. Thank you, guys.